So I will start with my question before we move to the questions for the audience. I normally start with this more personal questions, but as a nice segue from this particular discussion, I mean, if we take, so you're making the case that a conceptual modeling, you are taking a view of conceptual modeling and conceptual schema as things which describe the content that you should have in your information system, right? Now, if we take, let's say, a broader view on conceptual modeling, in which conceptual modeling is really about representing, to quote John in his talk, aspects of the physical and social world for the purpose of understanding, communication, and problem solving, it's almost inevitable that we're going to have a very large difference of expressivity between the languages which are used for such a purpose and languages which are used for structuring data, right? So maybe we need things which are very expressive for the former purpose. So don't you think there is a, that it's almost inevitable to have this disconnect between the expressivity in these two levels?
Yes, it's inevitable. That's the whole purpose of having ontologies in general. So you want to have ontologies because you want to have this very rich vocabulary that is closer to whatever you want to do. So again, I'm very neutral here. So all the work about cognitive plausibly ontologies and conceptual schemas, it can be implemented here. As you mentioned, the problem is how to connect this to actual information systems. And that's why in my personal line of research, I've started to explore approaches where these languages to express conceptual schema can still be very rich. And the APIs to connect to this is also very rich. So the query language is also going to be very rich. And I try to find the ways, the limitation of this. So by still keeping this notion of determinacy, which I just mentioned on passing, I find it crucial. It really means that, okay, I have this very expressive, very cognitively plausible, very nice ontology that describes this phenomenon. Then I have a very specific database that talks about this very tiny bit of this, but it's exactly the data I have that I want to deal with. Now, to connect the two, I only allow somehow the way to access this data that is complete with respect to the data. So I would not allow you to talk about things that you don't know anything about. So you can keep the larger ontology, but whenever you want to access your data, I would disallow you to query things of which you don't have the complete data for a very broad notion of what is complete data. Yeah.
So the complete ontology can generate different partial views for different purposes and different systems. Right?
Yes.
Very good. So let me go back to the past now in my traditional initial questions. So you are a physicist. Actually, I realized that we have a number of physicists in this series, Oscar and Yair and so on. So how did you go from being a physicist to getting interested in computational logics and knowledge representation and so on in the 80s?
Yeah, I guess that most people of my age were not computer scientists to start with, just because computer science was not an academic discipline, widespread academic discipline at the time. So when I wanted to enroll at the university, there was no computer science department in Rome, for example. So I had to choose whether to, well, there only were two places in Italy with Pisa and Bari, I believe, at the time. So I did not want to go away. So I did study physics as a second choice. Still, I made the thesis at CERN in Geneva with particle physicists, developing a non-representation system for the big experiment that led to the Nobel Prize 10 years later. So that's, I was already doing KR during my physics studies.
Mm-hmm. And was that already description logics in the very beginning, or something else?
Okay, you ask this because you know there is this funny story behind. So while I was doing my thesis, I met in 1985 John Milopoulos, who was visiting the place where I was studying. And he told me he gave a seminar on description logics, because description logic were invented 1 year earlier by Brachman and Levesque with this seminal paper on FL-. So he gave this presentation on FL-, and I got I found my dream, because I was already doing something. So the idea was to do something with expert systems at CERN. And now I say, no expert system. I want this formal notion of what KR is. And so John gave me the idea, and yeah. And then I met John again 20 years later.
Very nice. So you were basically self-taught in that sense, right? Because when you study physics, the type of mathematics you were exposed there is very different from this kind of stuff, from discrete mathematics and logics and so on.
Not really, because in the same faculty we had the mathematics department. So I did a big number of logic courses, including a course by Corrado Böhm and Jacopini, so the famous guys from the confluence theorem, Jacopini, Böhm. And then I had a number of people telling me about the foundation of computer science. I mean, really, really good stuff at the mathematics department, yes.
Mm. And also, you know, talking about self-taught, you know, people might know that, but you have this incredible achievement of becoming a full professor without ever doing a PhD. So people don't try this at home. So my question is, you know, after all these years, because you successfully supervised many PhD students. So after all these years, was there any point in time that you thought that you had missed something by not doing a PhD? So the question is, reflecting on the process of supervision, is there something that you recognize as a value in the experience of doing a PhD in itself? That
definitely. So well, again, when I graduated in physics, I could not enroll into the PhD of computer science because I had the wrong degree. And actually, in Italy, was just the first year ever having a PhD programs. No, it's very bad. In fact, I really suffered the first decade of my research activity because I was not really very good at it. So nobody really taught me, and it was very frustrating. I remember meeting with my gods, again, Maurizio, for example. At the time, he was always showing me, not that he was showing me, but I understood by meeting him and his group and other groups in the world that there was really, really little guy that needed to study much more. And it was so the first years was very frustrating. At some point, I was even thinking, okay, I will never do something interesting. I still believe I'm not doing something which is so interesting with respect to the people I really admire most. But yeah, here I am.
Enrico, we miss you there for a while, but
sorry, what happened?
So I mean, you were saying that you were discussing that you were in contact with Mauricio and so on, and that you realized that you needed to pay attention to certain things, right? I had the impression you're going to say that you didn't do things interesting, but I would strongly disagree with that.
Well, I don't know. No, I didn't say really that. I just say that it was very hard, and at some point I even thought that I was not just right for the job. But well, here I am.
Very good. Now going back to I mean, I asked this question because as you know, we have many PhD students here, right? So it's a good idea to give them to identify what is the value of the experience. And sometimes people that have been doing this in a very clear segue don't realize that so much as someone who is supervising people without actually going through the experience. Description logics, right? We were talking about this. I remember, in one of these Tagstools that I had I have this chronic insomnia, so I couldn't sleep. I was reading the manuscript of this 1991 Tagstool, which was the first DL workshop, I guess, right? And all these very interesting people there, you and Nicola and Peter Patel Schneider and Ron Brackman and Deborah McGuinness and so on. So this was the very beginning of the community of description logics. And that was, I don't know, 10 years before that they were even considered for as the language behind this whole project of the semantic web. So two questions on that. First, I was going to ask you to reflect a little bit on the beginning of description logics, and in the end, why was this thing chosen as the language for the semantic web? Among alternatives, and was that the right choice, the particular language which was chosen for that purpose?
Okay. My view, my perspective of the beginning of the DL period, the golden age somehow, the 90s of DLs. What the community wanted to do really was to clean up the mess that was happening in knowledge presentation, motivated by an important problems in AI, natural language understanding, planning, universal general problem solvers, expert systems. So there was a large number of applications in AI that were using ways to represent knowledge, and they were using these systems, these ways in some way, somehow. But this was a huge mess. So this was the period of important papers like what's in a link. So what this semantic network would mean. I just, this is nothing to do with 30 years ago, but has to do with now. I believe that something is happening very similar now with knowledge graphs. So many knowledge graph variants approaches are, in my opinion, a mess, and they would require to be cleaned up. But apart from this, so going back to 30 years ago, so the excitement was to find the essential meaning and formalization of all these notions. So this at the beginning was really involving linguists, psychologists, cognitive psychologists, logicians, mathematicians, and computer scientists, of course. And this was really an exciting period. And then later on, the DL community somehow split into various subparts. The one that became just formal mathematicians, others that were going more towards systems, others that kept the connection with the original motivation of being the engine behind the AI application. And this led to the second question of yours, which is semantic web. Yeah. So because, again, for representing knowledge, this was really the description logic where what happened after a decade of thinking how to clean up the mess of knowledge presentation and come out with a formal understanding of it, in particular from the computational point of view. So this means also practical point of view, not just mathematical point of view. Well, when the semantic web effort started in the late 90s, it was easy to pick up this approach because it was the only one which was really done in depth with systems and proofs, efficient APIs and stuff. Not that I don't know whether you really mean also this in your question. You ask whether DLs were the right choice for the semantic web. The point is that they don't know what the semantic web is, but that's I teach a course on semantic web, and they say exactly this. So if you see the semantic web as a bunch of technologies, fine, it's tautologically true because one of the technologies of semantic web is OWL. But if this meets the requirements of the semantic web as such in abstract, I don't know. I even don't think so.
Let me ask this question a different way then. I mean, I think I've told you this. I mean, you are, in my view, one of the founding fathers of the original idea, and I think people don't know that because you chose to distance yourself from this, I guess, right? And I guess also because you were critical of some of the choices which were made there. So, what do you think as a project? This community got right, and what do you think it got wrong? And in the discussion of the particular choice of technology, I remember people were considering DL versus data log and things like that back then. So I mean, also on that, was that tell us a little bit about these discussions and the reason why people went in that particular way.
Now, I don't think there is anything wrong in whatever choices people has made in this community. There are simply different choices with different goals. I had a different goal, as I mentioned at the beginning. You mentioned at the beginning, I have this goal of making these things much more coherent with current technologies, and so less focus on abstract problems, but more focused on, I started with expert systems and then went on with natural language, real parsers, how to connect knowledge representation with actual parsers, and then with Montague-style semantics. So I did a number of work that really were about, there is this thing in the real world, very nice, very formal, that works. How can I add on top of that this notion of semantics? People did other choices, which are really necessary, because without real theoreticians, without people developing systems, without people doing all this kind of stuff, that the field would not have evolved. My choices are just personal because I like more to do this stuff, but there is nothing wrong in doing all this other research, really. Yeah. Then, of course, when I talk about my choices, I also say, well, I choose this because I believe A and B and C, but then this is just a scientific discussion, right?
Right. Yeah, sure. Yeah, I mean, I guess you see yourself nowadays more as a database person, as a foundations of database person, than as an AI person, right? So at a certain point, you got more interested in foundational problems in database. Would that be correct? And no. Is the reason connected to this? No?
No, I know nothing. I know nothing in databases. I know nothing in representation. I'm just trying to focus on very niche areas and trying to do the best I can in these niche areas. So I am not definitely a database theoretician. I'm not a KR theoretician. I'm not even a real practitioner, because I'm not building the top of the mark systems. I'm not selling anything. I don't know. I just focus on these problems and try to clean them up. So cleaning up is one of the things that I like most.
Now, one of the things that you have been busy in the past years is ORM, right? And the collaboration with Terry and the formalization of ORM by having this kind of mapping to DL, formalization and reasoning of SBVR as well, and also with these practical tools that I mentioned in the beginning, with ESA and so on. So I guess the first, I was going to ask you to tell us a little bit about this work on the reasoning support for creating models in ORM. Yeah, I'll ask this question. Then there is a follow-up one, but let's start with that.
Okay, so again, the reason why I was involved, I decided to be involved in ORM is because, well, again, non-representation and conceptual modeling are really the same thing. There are conceptual modeling languages and a framework and methodologies which are geared towards databases, and I wanted to look deeper on this, or software systems, software design, so UML would have been. But again, from the formal point of view, so that not even formal, the foundational point of view, again, these approaches were a mess. So I started looking at UML, I started looking at various conceptual modeling methodologies, etc. They were a mess, foundationally speaking, perfectly working, nothing to say, but my focus was this. So how can we fix that mess again? And so I started with UML, spent a couple of years in the UML committees and stuff. I left disgusted, to be fair. There was no attempt to listen to issues that were foundational about UML. So, well, at the end, I found that this, what was this unknown language like ORM, the fact-based modeling approach methodologies, had this godfather, Terry Alpin, who is a philosopher. Well, you have listened to this a few weeks ago, and is a logician. And in his PhD thesis, he actually formalized this conceptual modeling notation of him, ORM. So starting from there, okay, I said, now I can really do something nice, understanding. So I started from there, and I got interested in ORM. And just because I didn't want just to go to Terry and say, look, I'm interested in this, I spent 2 years to understand myself ORM, and we implemented with a couple of PhD students a system on ORM. And then when this was ready, I contacted Terry and his group, showing him, look, I've done this, are you interested? And then we started a cooperation, which led at the end to a document which is in public discussion stage now, where is the formal definitions, syntax and semantics of ORM, so that starting from there, in principle, you could start really formalizing systems, methodologies, tools, and stuff.
And this was, as I said in the beginning, an evolution of this preliminary work you did with ICOM, right? This pioneering work you did with ICOM. That was in the 90s, right? Beginning of the 90s, ICOM.
87. First ICOM was 87.
And I think there are really two cool ideas in that project, right? That it's been, going on for a long time. One is this idea of having some sort of kind of almost an operational semantics when you have this graphical language mapped to something that will give you feedback and show you the consequence of the reasoning, right? But the second one is something that in doing that, you are separating the language that you use to do reasoning and the language that you use to think about the models, right? And this is something that maybe it would be nice for you to comment on that as well, because despite the benefits of DL and all that, it is really a mistake to use that language as your interface language to think about the models. I've been making this point for a while, but you've been making this point even much before me. So could you comment on this?
Okay, so I just admitted that you are saying this, and I agree with you. So I believe that real practitioners of conceptual modeling for information systems, I focus on this, but also people willing to build ontologies, well, maybe in your sense, or cognitive plausible or holistic ontologies for modeling a domain for documentation purposes, medical domain, biological domain, even if there's no data attached to it. I believe that it's much better to use this notation, which are well known in terms of design methodologies like UML, ER, ORM, of course. Because at the end, what you want to design is a conceptual schema with some additional notions that come from the, say, cognitive plausible or formal foundation or whatever, but somehow all the basics are already there. In description logics, and most notably now, there's really no serious work on the design methodology for these languages. There are some attempts, but to me, they do not reach the depth of database design, serious or software design, knowledge acquisition. So it's plenty of work on how to build proper, even in the classical sense, conceptual schemas, no matter whether they're null or not. So I believe that then people should interface with these kind of languages. Of course, then you can prove that these languages are nothing more, nothing less than OWL or whatever. There is a mapping of OWL. You may lose something, you may have something more, probably not. But the fact that these people have invented this language and they are using these languages, they're probably finding these languages useful. And if we basically find that 98% of the construct in these languages can be mapped into OWL in the background without you knowing, then I prefer to expose people both in input and output. So when they write and when they get feedback from the system, using their own high-level language. That's my opinion.
I see. One of my final question before I move to the audience, to the questions from the audience. I mean, I think my favorite paper written by you is your paper on reasoning about part-whole relations and the papers on collective entities. So this was also like, 20 years ago or maybe even more. And this, and it's no surprise that I like those papers because they are more than ontology just in the logical sense, right? So you're connecting to mereology and to all those things. So you were doing a lot of this in that period, working on taking things from ontology like mereology and trying to do this kind of formal treatment that would allow for reasoning. And then, after that, you got, let's say, less interested in doing that. Is there a reason for this?
It's called AI winter. no money for it, really. That's it. So you wanted to do research, you better focus on things that European Commission wants to fund. So in the 90s, there was a lot of natural language, cognitive science, and knowledge design and stuff. Then this thing ended, really. So I would love to go back, for example, natural language semantics, or even just classical natural language, even forget about KR or logic or whatever, but approaches of natural language understanding which are based on what people know about language, grammars, semantics, lexical knowledge, so whatever. All these things have been forgotten, and people don't fund ever a project on natural language semantics because, well, neural networks, they do all the job for you without you understanding why, but they actually work very well. So why doing foundational research if in practice they would translate this for you, they would annotate the text for you, and they would all the practical tasks you may want to do with natural language much more effectively than going through the hard route to try to understand what's going on behind. So yeah, this is probably one of the main reasons, AI winter.
The future of knowledge representation and conceptual modeling, given that, in your opinion?
I can't tell, because in what is my future is one thing, what is the future of the community as a whole. I've seen that, for example, many people are trying to work on this knowledge graph. So if you focus just on KR, on knowledge graph, they're trying to exploit all their knowledge there, which I think is very interesting if done properly, and many people do it properly. But there are other approaches which would be interesting to formalize and include in this proper way of doing stuff. For example, in our group in Bolzano, as Giancarlo, you know, of course, they are building there is also a startup that's built the best system in the world to deal with knowledge graph in a foundational way using this OBDA approach. So I believe that this is excellent work. This is going to be successful, again, for all the application where these things is needed in this particular framework. Deep AI, deep KR, theoretical AI will go on because there is always the need of having results which, for example, there is an area which I believe more studies, and many studies have been done, but even more are needed, which is the temporal knowledge, spatial knowledge, movement, and so the idea of talking about specific domain, topology, and stuff, and having this integrated in more classical approaches. This would be very interesting, because in perspective, this is going to have a lot of application. Again, in our group, we have people doing that in temporal knowledge, for example.
Well, you did yourself quite a lot of work on a temporal version of ER, right, in the past,
yes,
with Alessandro Attali. But now, with the focus on ORM, which is a kind of timeless language, did you lose interest on these temporal aspects and modal aspects of modeling?
No. Okay, two aspects here. First of all, the study temporal stuff is hard. Not the study is hard. The outcome has a high complexity. So if you want to use these things, you have to really understand the limit, how to limit the whole approach. And this is an ongoing work. I'm discussing now, because also these things become very technical. I guess I lost my expertise on this much more technical stuff, but Alessandro Attali is doing this stuff. We always talk about in the corridor about potential direction of real applicability in temporal database system. For example, it's amazing that there are all these works on temporal logic, temporal knowledge representation, but there is no connection with temporal database technology, with TSQL. This is something I would be interested in doing. But my what I'm willing to do, actually, I did a master thesis on this, is using the temporal notion, a weaker temporal notion in terms of persistence. So the thing that basically are a variant of onto-clean operators. And I believe that this weaker approach has a better, of course, computational property, but also an easier applicability. I don't know. I would start with this small addition to conceptual modeling, and see what happens, and see, of course, how this connects with actual TSQL stuff, and then maybe go to the harder ER, temporal ER studied 10 years ago.
Very good. I think this is a very, very interesting direction. So let me move now to the audience. So there are many questions here, Enrico. So the first one is, most NoSQL database use a schemaless approach. Is this approach desirable?
Well, maybe yes, of course, because I'm just talking about how to use schemas with databases. If you have a schemaless approach, maybe, and you want to remain schemaless, so that's the whole point. So think about RDF now. RDF is schemaless in the sense that I can have really classes connect to anything, and so it's completely free. No schema is inconsistent. No instantiation. All the legal databases, all the database instances are legal. However, then the schema comes from the back door, because if you want to efficiently implement in a database system RDF, you probably have to do some statistics on top of your actual RDF database, RDF graph, to induce the existence of classes and relations and foreign keys and indexes and stuff, so that basically you avoid to write the schema in the first place, but then you ask this database system to guess one for you, otherwise it would not work. Now, my personal opinion, this is crazy. So if really you want to go schemaless, so you have really to have a scenario where this is crucial. I don't understand most scenarios where people use NoSQL or schemaless approaches like RDF. They are schemaless just because people are lazy. So I would really say that you should use conceptual schemas as much as you can. And then if the scenario, for example, you have an evolving information, you really don't, things are widely changing over time, so you can't really fix a schema once forever, then okay, fine. But in general, I believe that schemaless is an excuse for being lazy.
Okay, next question is from Bernard. I think that's Bernard Solheim, so I mentioned him because he will be an EROSS speaker in 2 weeks, so we're very happy about it. So thanks, great theory. Your notion of lossless transformation is very strict. Why not use information morphism, infomorphism, instead of a total injective mappings? In this case, you could also cope with the case that the schemata may have completely different structures. Then you can translate objects from one database to the other one, even if the structures are different. Think, for instance, of schemata in your language, and XML schemata with a Russian doll orientation on data, with lots of redundancy among the documents.
Okay, I'm not sure I fully get, but I think that the problem of having completely different structure is covered by lossless transformation. The lossless transformation is a very general notion, is the fact that the information is always the same, no matter how we do a structure. So I can, if this lossless transformation exists, if these two schemas are equivalent, this means that these two schemas will hold the very same data, and they can reconstruct one from the other always. It's just very abstract notion, so this captures any possible notion, because the existence of a mapping tells, okay, I have this information here, injectively I get the same information expressed in this other place, and is bijection, so it works, right? And it's so general, I don't see why examples like yours cannot be captured, but probably I don't fully understand your point.
I think that conceptual schemas are interpreted with open world assumptions, while relational database with closed world assumption. Is it in this sense too strong to ask for a complete equivalence?
Okay, this is, I guess that your thought is just wrong, because conceptual schemas are constraints, so they are just interpreted as a bunch of constraints, and they represent a set of legal database instances. A relational database is a bunch of facts, so it's one relational structure, is one of these one of these legal instances. So in particular, in databases, there is no closed world assumption, because it's not a language logic, it's just a structure. So it's just information there. So I guess here it's just a matter of understanding each other. And I guess I showed that even though conceptual schemas are just plain logic, so in a sense, as you say, they are open word assumption, even though the acronym open word assumption is meaningless, CWA has a meaning, but OWA does not have a meaning. It's just classical logic. But in your sense, I believe this means open word assumption for you. Yeah, so I have a conceptual schema which is open word assumption, a relational database which is closed in a sense, but not in CWA, which is a syntactic notion, whatever. But yeah, I can connect the two. And this is exactly what they do, what people do with even not just me, ER, so code, and Peter Chen. ER is open word, and the database is closed word, and there is a strong connection between the two. So I don't believe your thought is correct. But again, it would be nice to have a discussion with the audience.
Yeah, that's a pity that we don't have a discussions, and I have to sometimes maybe super interpret the questions. Can you comment on the standardization in conceptual modeling? Do you see now a move away from standards like UML and OWL, or they're more established now?
I think standards are important. So UML is a standard, but is not well-founded. OWL is a standard, it is well-founded. And as an alternative to UML, that's why exactly I'm studying ORM, the fact-based modeling approach, and which hopefully will become a standard, at least de facto. We're organizing a DAX2 seminar on this, try to gather people on this, discussing about this. But yeah, there will be standards, because without standards, you don't have interoperability, and this is just crazy to invent languages that nobody actually uses, I guess.
Do you see people arriving to conceptual modeling nowadays through similar steps as you did? What kind of paths do you see researchers in the field taking?
Oh, but conceptual modeling as such, at least in my experience, is not really the way I understand it. So study methodologies, general absolute methodologies, and formalism for conceptual modeling is not a very wide area. So I'm not sure that people nowadays, since the beginning, know about research in conceptual modeling. I don't know. Maybe if you just mean KR, I don't know.
Yourself, KR is kind of conceptual modeling, right? And
yeah,
yes. Learn how to do ER diagrams in any database course in the world, and UML diagrams in software engineering and all that, right? So there is spread in all these different areas. In a sense, although there is this 4 decades conference in conceptual modeling, so well-established community.
Yeah, I guess there is the sub-fields of conceptual modeling. This could be methodologies, databases, software engineering, foundations, KR. They are too much disconnected from each other. That's probably an issue, and I would dream of anybody doing conceptual modeling in the ER community, for example, to understand everything that involves conceptual modeling, from the foundations to the applications to at least have an idea of everything, right? But probably this does not happen yet, because it's an emerging field. So we still need a sort of unifying theory.
Is computer science more welcoming to people from other fields nowadays? I guess because you mentioned that, being a physicist and people blocking your PhD because you had a physics degree.
Well, I wish. So I would actually, the people that are in our group that I've built from scratch, it did include linguists, philosophers, mathematicians, computer scientists, of course, logicians, and software engineers, people doing learning. So I think that really it's in the case of KRDB field, multidisciplinarity is something which is actually happening. If you ask me about computer science in general, I don't know, because I'm not a computer scientist.
In your opinion, is there any hope for the project of the semantic web as taught by Tim Berners-Lee, or is it destined to be a bunch of different localized semantic technologies?
No, I think that the project is open, and eventually something much more successful will happen. We have to understand exactly which technologies, which ideas, which framework, which methodology will be applied. But the dream is a very valid dream, is basically to have this distributed network of information, loosely coupled and but integratable with these common vocabularies, and which really call for the existence of these ontologies and integration process. So it's basically a huge motivation for research. The research will go on, and is still unsolved as an issue. Is more complex than another very crucial issue, much more practical in databases, which is data integration. Data integration is a very small sample of the semantic web idea, and which is still an open issue if you think about it in companies and the real world, in the SQL world. So, but people are working hard on this.
Then there is a comment that you should submit ORM to the OMG now that you have things like DOE as standard.
Not interested.
Not interested. In this standardization process, I guess.
No, you don't really need a standardization process so far, in the sense that I have been in the groups for OWL, RDF, Sparkle, and my experience is that where something goes wrong, if it is led only by research and not by the fact that the industry has a standard de facto which wants to standardize. But doing the other way around probably would not work. So I would wait to really get feedback and applications and stuff before standardizing.
Enrico, what's the correct interpretation of null values, and what are the ways people get that wrong?
Oh, okay. This was one of the chaos, one of the things I wanted to understand and formalize. The notion of null values in SQL, so the standard notion of SQL null values. And turns out that the theorems, the formalization says that the meaning of null values is no information, or alternatively, no information or existing but unknown. So, but this or, because of whenever you have unknown information, you need, as explained today, the notion of certain answer, you can prove that there is no difference. So understanding SQL with a no information null, or understanding SQL with no information or unknown null. So I don't know whether this null means no information or means unknown. These two understandings are equivalent. And again, if you really think about the second understanding, the one which says I don't know which is the meaning of null, is really misleading. Because it's in the way you use query languages, and the way actually also SQL understands query language, being a query language, is that there is a certain answer semantics, and then what you get out of it is just the case that there is no value, because there is always a model where there is no value.
Enrico, I think we have to wrap up. It's been a pleasure. I mean, I have the privilege, or I had this privilege of doing this almost every day with you before COVID. But it's nice to get this on record. So it's been very nice. Thanks a lot.